Jim Kunkel here. Make sure that you subscribe to my channel and set the notification bell to all so that you won't miss any of my new content. On this episode of Global Topic, we'll be talking about the subject matter of coating dry film thickness, or DFTs, and scanning technology in conjunction with SSPC PA2 standard. With me is Christopher Platt from Alcometer. Christopher, if you could explain your role and what Alcometer does.
All right, thanks, Jim. Thanks for having me on. Like Jim said, my name is Christopher Platt with Alcometer. I'm an outside technical sales rep. Pretty much with Alcometer, we are a manufacturer of coating inspection equipment for many different lines, everything from coating thickness gauges to blast profile gauges, gloss meters, even lab equipment. And we recently just came out with a blast line as well. And we are also worldwide.
Oh, very interesting. Very interesting. So, Christopher, when it comes to electronic data collection with an inspection equipment related to coating dry film thickness, or DFTs, what inspection equipment options are available to the industry from Alcometer?
For DFTs, you've got your type 1, your mechanical gauges, and then you've got your type 2, whether it be your traditional, I guess you could say, point and shoot gauges. Take one measurement, get one reading. You also have your fixed calibration units, and then you have your scanning DFTs as well.
Okay. When it comes to obtaining, DFTs, when coating inspection is being done, what are some of the methods, conventional, fixed, scanning, that are currently available to the protective coatings inspection industry?
So with your, would you like me to go over how each of them works, or?
Yeah, go ahead.
Okay. So with your conventional unit, your type 2 conventional, you have a probe on the bottom. You take pretty much, if you were to have my hand, I don't have a gauge with me, but if you were to take one measurement, you get one reading. The inspector could either put it into save it in the gauge and later download it to a computer, or they can manually write it down on their inspection report. To calibrate those, you generally calibrate to whatever blast profile that you are going to be measuring off of. With the fixed calibration ones, you go through and you pretty much select whatever blast profile on steel that you would be measuring, and it will auto-calibrate to that blast profile. Using that, you do take away a little bit of the resolution of it, but you calibrate right to that blast profile every time. As for the scanning one, the scanning method, you would calibrate the same way as a conventional, except at the end, it would ask you to attach a scanning probe cap to it so that you can offset that calibration.
But very interesting. Go ahead.
Oh, yep. Those are the 3 different ways that you would be able to use it.
Okay, so when looking at SSPC PA2, in its last major revision, it added an Appendix 10 to address the Type 2 dry film thickness gauges. That perform the continuous, real, read scanning probe technologies out there. Can you please explain the procedures to obtain scanning batch readings according to the SSPC PA2 standard?
So with the scanning batch readings, I believe that you are going to be taking, you are going to change a little bit. Where you would take 3 measurements, I believe you're now taking 12 measurements, and you're using an infinity symbol, so pretty much just like a figure 8. And you take 12 readings in that area. You'd still follow your same, or 12 different spot readings, but you'd still do it in 5 different areas as well. I believe it's over what was that? I believe it was it 4 inches that you're supposed to measure that infinity symbol over? Okay.
And then typically with that type of data that's collected, is it automatically something that's recorded in the device, or is it can be real time put into a reporting software?
So depending on the software that you're using, you can have it put right into the software right off the gauge, as long as you're within a Bluetooth distance. I believe that's about 22 feet of a whatever device you are using. So whether you're using ElcoMaster or TrueQC, both of them can take real-time readings.
So, in your experience, in obviously, providing these the equipment and the solution to the industry, are you finding a heavily shift towards the scanning technologies?
I've been seeing it pick up quite a bit over the last couple of years, especially now that it is allowed in PA2. Well, it's an appendix of PA2. At the end of the day, time is money. And if they use the scanning technology with software at the same time, you can cut inspection time down by, I believe it was, let me pull up my notes. I believe Naval Research Laboratory said it was a reduction of almost 86%. Let me pull that up. So the conventional way of measuring, say it takes you 30 seconds to take a reading, between taking the reading, writing it down, and then filing it later. So we'll say 30 seconds of reading. You got to take 125,000 readings. It's going to take you 1,000 hours, which is 125 8-hour shifts. And it's going to take 3 inspectors about 2 months to do all of those readings. If you were to, with the scanning technology method and using the software with it, it takes about 5 seconds of reading, which is significantly faster than the 30. So 120,000 readings is going to take you 167 hours, which is about 21 8-hour shifts. So 3 inspectors could do it in about 1.2 weeks, which is quite a bit different than 2 months.
And it, with this type of technology, it doesn't, obviously you gain speed and efficiency, but you don't sacrifice the quality of the reading.
What was that?
With the scanning technology, you gain efficiencies, you save time, but you don't sacrifice the quality of the readings. The readings tend to be more accurate, you'd say?
They do tend to be more accurate because you don't have as much of a standard deviation. So when you get a lot of your erroneous readings, it comes from you constantly lifting up and putting down that probe. And if you don't seat that probe correctly, or you're a little bit off, or say you hit a paint bubble or something like that you didn't know was there, all of a sudden your readings out of tolerance, that can throw you out. With the scanning, you put the probe down once and you're actually sliding it across the surface. So you never have to lift it back up again. So you're actually just gliding it along, so you're not resetting it every single time.
And the use of the technology, it's relatively easy to learn to use.
Pretty much the hardest thing about it is just adding that cap at the end of calibration. If you have an inspector that's used to the conventional Type 2 way of measuring, they should have no problem getting used to a scanning probe as well. I find the scanning probe to be a little bit easier, just because I can put it right down on a surface and just glide along it. 12 readings will take you about, not including the inspection reports, probably about 5 or 6 seconds.
Oh, very interesting. And then with the type of technology you offer related to the scanning for scanning DFTs, is there software that you also have, a software platform? You mentioned that this can interface with like TrueQC and other type of programs that are out there.
So we do have our software, ElcoMaster. It does come with the gauges, or you can download it offline. It is a very simple software to use. Pretty much it'll only connect to our equipment though. And then you can get into TrueQC, which can manage a lot of other things that ElcoMaster cannot. And it can connect, I believe, with multiple types of gauges.
Oh, very interesting. So, Christopher, we covered a lot of topic related, obviously, to the technology, the use of, related to scanning technologies with dry film thickness. Is there anything that we didn't talk about that you should want to address to the viewers of this episode?
Not that I can think of right off the top of my head.
Anything anything new or exciting coming out of Elcometer here in the second half of 2020 or going into 2021 that you want to kind of preview?
Not too much right now. We're just kind of focusing on our blasting line. But I will say this, back to your original question. Um, Biggest thing that I see out in the field, make sure that you calibrate to your blasted profile. I cannot tell you how many times I've walked onto a job site or something like that, and you have people trying to take DFT readings and they're calibrating off of a not blasted piece of metal.
Very good. Very interesting. Well, Christopher, I appreciate the opportunity and the time to talk with you, and thank you very much.
All right. Thanks for having me on.
All right. Have a great day.
You too.